All right, welcome back to Mr. P Helps with Calculus. This is Unit 3, day number 2, and we're going to be exploring some more chain rule questions. Now, more importantly, we're going to be doing ones that are a little bit more difficult, ones that are involved inside of product rule and quotient rule, because they're not going to be always as easy as the last video. And we're going to see some examples today. All right, starting off with this is an activator that's very similar to what we did yesterday. I know I don't always do the activators, but it's very important to what we're doing today. And we start off with question number 1, which is a triple chain. It's got 3 functions. Now, I like to change, even though this is the most common way of writing trig functions, I like to change it into this. So that's a little bit more obvious that this is the outer, and that this is the one in the middle, and that this is the most inner function. So you remember, you're looking for, those brackets or parentheses or absolute value symbols, something that shows you what's on the most inside. You always work from outer to inner. So using simple power rule, you bring the 3 down and drop it down to 2, of course. And then you do the derivative of the middle function, which will be cosine of 4t. And the derivative of the inner function would be just 4. And this is a matter of cleaning up and rearranging it. Remember, you can only multiply things that have the same power. So like 4 times 3 can be multiplied to get 12. If this was 4 to the second, then you couldn't do it. Well, you could do 4 to the second, which is 16, and then multiply it once it's to the first. All right, this one over here looks like we have just a double chain. We have an inner here, and we have an outer here. So 4 times 5 is 20. Keep this all the same, drop it down to 3, then multiply by the derivative of the inner function. Pretty straightforward chain rule question. This one's also pretty straightforward. I know it looks like it's a triple chain, but it is not. This is the inner function, and the outer function is just going to become 2/3 because it's power over index. That's how you write your exponents. So this is power over index. Now, you could, I guess, you could make it a triple chain and then say, okay, let me just show you because it's going to be hard to explain. You could do this. It is possible to do that. I just don't see any reason to do that because you're going to end up getting the same answer anyway, because 2 times 1/3 is 2/3. When you have a power to a power rule, you just multiply the powers. Power over index is the easy way to think of it, though. Power over index. Okay, 2/3 drops down in front. Drop this by 1, then multiply by the derivative of the inside. I think it's pretty straightforward from there. Now, you've seen a question like this on the last video. You remember that, you could use the quotient rule here. It's possible. But I think the quotient rule probably is going to be a little bit more work, especially with this chain on the bottom. Okay, so let's just throw that idea out the window. I can already tell now with this squared here, that's going to make that a lot harder. So I wouldn't want to do quotient rule in this question. So the first thing you're going to want to do is take all of this, put it to the top so that you can have one straight term that you can use chain rule on. So you have the inner function here, you have the outer function here, and this is essentially, you could just move that to the side if you really want to. You could just say that's the constant multiple rule. All right, -2 multiplied by -7 is 14. Even if you multiply it later using constant multiple, you're going to still get 14. Drop it by 1, and then multiply it by the derivative of the inner, and then the rest is just cleaning it up. Really not a whole lot of work when you do it this way. Quotient rule would have been a lot worse. All right. Very important when you see a question like this, which doesn't have parentheses, but you know that anytime there's no parentheses and 2 terms are next to each other, you know that's multiplication. This is really 4 times x to the third times cosine of 3x squared. Now, why is that important to recognize? Because this is product rule. This is product rule where this term's being multiplied by this term. You could put the 4x cubed together, or you could pull out the 4, which I did using constant multiple rule. It doesn't matter. You're going to get the same answer either way. Now, this is product rule, but this product rule, when you do the derivative of the second term, you're going to have to use chain rule. And that's how chain rule really is applied. You're not going to see questions on the AP exam where it's just one simple chain rule. Well, I guess it could be, but it's not most likely. It's going to be, you're going to be given a question, you're going to have to use chain rule in that question. And this is the kind of question you might get. You might get a product rule question where you have chain rule being applied. How do I know it's chain rule? Because this is the inner function and this is the outer function. So yeah, when you do the derivative of the second piece, which is, looks like it's over here, let's see, I did first times the derivative. No, it's right here. Sorry. So derivative of cosine is negative sine of 3x squared, and then you multiply it by the derivative of the inner function, which is 6x. And then plus the second term times the derivative of the first term. Now keep in mind, I didn't do the 4. That's maybe you don't want to do it my way because that might get confusing to you. I didn't use the 4. Ooh. I think I might have messed up then. I multiplied it by 12x squared. Oh, I did mess up when I did this. Oops, I guess that's why I shouldn't do that then. I pulled the 4 out as a constant multiple and then used it here. This should have been 3x squared. Oh, I fixed it on the next line. Oh, that's interesting. I had it wrong here and fixed it on the next line. Maybe, I don't know. Okay, whatever. All right, found my mistake. 4 times 3 ended up being 12 in the end. Okay, so everything all worked out. All right, number 4. Once again, could I, oh no, it took me a second to evaluate this. No, I cannot just use, this is the inner function here, this is the outer function here. You're kind of forced to use chain rule. So outer function first, drop that 2 down, drop it by 1. That's what you see right here. That's the derivative of the outer function. This is the derivative of the inner function. Now, to find the derivative of the inner function, I had to use quotient rule. Now, I guess technically you could turn that inside into a product rule question. Now, if you don't know what I'm talking about, it's an option. I just wouldn't do it. You could change it to 3x minus 1 times x squared plus 3 to the negative first. But by doing so, you now have an outer and inner. You're just adding another chain to that product rule. So I wouldn't suggest doing that. It's an option. By all means, try it out for yourself and see if you like doing it that way. Your teacher's not really going to care, nor do I, how you arrive to it, as long as you show the work that it doesn't matter which method you chose to find this solution. I would just keep this as a quotient rule question right here. I know it looks like it's a lot of work, but once you've done it a bunch of times, it becomes easy. Low D high minus high D low over the bottom squared. Low times derivative of the top minus top times derivative of the bottom over the bottom squared. And then it's just a matter of simplifying it down. All right, so let's look at some table questions. Now we've done a bunch of those. Other ones with quotient and product rules, so we also got to know how to do it from a table. Given the a of x, this is what they like to do on the test too. They'll name the composite functions named a of x. And a of x is equal to f of g of x. So they're telling us what a of x is, and then they're asking us to find a prime of 0. The first thing you're going to want to do is find the equation for a prime of x. So you're trying to find, okay, well, if this is a of x, if all of this is a of x, what would a prime of x be? Well, that's essentially just the chain rule. A prime of x is the composite function, f prime of g. So derivative of the outer function times the derivative of the inner function. Then I'm going to take 0 and I'm trying to find this, so I'll plug in 0. Then at that point, then I'm going to start substituting things. The most inner is g of 0. So I look up here, g of 0 is 1. Then I can find f prime of 1. F prime of 1 is negative 1/3. G prime of 0 is 1/3. And then it just becomes a simple multiplication question. The key here isn't this part. This part should be really, really easy. The key is making sure you understand this first part. If they're telling you the name of the composite function, they're asking you to find the derivative of that composite function, you got to show how you got that equation. Then you then you plug in your zeros, then you substitute whatever the values are, and then solve. And usually these kind of questions are usually pretty easy math. Very likely these would be a non-calculator question. All right, same thing here. They're telling us the name of the composite function. They're giving us what it's equal to. Derivative of the outer function times derivative of the inner function. Plug in your zeros, substitute, and solve. You can kind of go through the rest. Just looking at the table, that's all you really got to do. I kind of had a mess up on this one. F4 of x, just so that you're aware, this is a very rare thing to see on the exam. But this actually means something else. This really means fourth derivative of x. So when you see f4 of x, that's fourth derivative of x. because anything above third derivative, you just start using a number. It'd be kind of silly if it was f8 of x and you would actually put 8 little check marks, because that, it'd be hard to count, I guess, once it gets beyond a pretty big number. So you just start using numbers. I think what this was designed to be was this question, so that we have chain rule involved. So 4 gets dropped down here in front, 4 became a 3, and then essentially we're just plugging in and solving, and I got 108. If it was designed to be like this, you couldn't do it, to be honest, because once you got past the first one, there isn't enough tables and there's just not enough information to solve. You couldn't find the second, you couldn't find the fourth, let alone the third or even the second derivative. You could only find the first. And that's it. Thanks again for watching. I'll see you on the next video.